Next, modeling application. Why we model, replicate, simulate the real system using the computer. And these apps, we call them CAD. Type it down, CAD. Computer aided design. Note it down, please. Computer aided design. Meaning, we can use some app in the computer to design certain things before we start manufacturing or building them. So we simulate first. Yes? We start to simulate. Now, why we simulate? Look, why we do simulate? To see how the system behave. For example, if I'm building this bridge here, look, if I'm building this bridge, what do I need to know? The local load of cars. What will happen if there is a flood? Will the bridge stand or collapse? What will happen if there is an earthquake? Will this bridge stand or collapse? What if I run the simulations for different factors for 50 years? Will I find the bridge still there? You get the point. So using the computer, you can apply different changes and see what will happen. If you will find that something is wrong, you can re-change the design and again run the system and see until you get what you want. The same goes for if, for example, you are building a house. Instead of building and then changing your mind, adding walls or removing walls, you'll do it where? Inside the computer using these kind of apps, and then that designer will always show you can make changes until you are satisfied, and then the designer will say, are you okay? Then we'll go and build the real house. Are we good? So what we do, we try to simulate the real system. Why we do it in the computer? Why we do it in the computer, generally speaking? They are less expensive, isn't it? You'll find that they are less expensive. Let me go back. Yes? So you will try and see how the system, you can predict the behavior of the system to influence the future. If you would like to build a bridge that will last for 100 years, you will make sure that inside the computer you put all the factors to make it last 100 years, and then you can go and build the more expensive one. So advantages, if you look, what we have in the advantages, it's less expensive. It is safer. What do we mean by safer? Because if it collapses, the simulation collapses, not the real thing. And you can model or simulate dangerous things like nuclear, for example, planets or nuclear reactors. Whenever you do these kind of nuclear reactors, if you do them in the computer, nothing will happen, no radiations, isn't it? But if you are trying to test in a real one, then you might be in danger. Are we good? So you'll find that, generally speaking, it's very safe. Next, you can apply different scenarios, and we mentioned it's very fast. What's the disadvantages? The accuracy of the system depends on the programming, meaning if you have a solid application that can put in mind each and every tiny factors, then this, what you can call it, the output of the systems will almost be the same like the real one. It will not be ideal, of course, isn't it? Simulation is theory. Practical will always be different. But if you are investing in the simulations, put in all the factors, you haven't forgot a factor, you will find that you will get almost similar results whenever you build the real one. Are we good? So it will never be as accurate as the real things. And these softwares tend to be expensive. Whenever we go into university, if you are going for architecture, you will find that certain software are very expensive. You have to lease them, you have to pay for them. Yes, annual subscriptions. Are we good so far? Yes? So as you can see here, a couple of points that we have discussed so far. And example, what are example of modeling? These are the examples. You need to know these examples, by the way. You need to memorize at least 3 of them. When they ask you, define modeling, mention advantage and disadvantage of modeling, or examples of modeling, you have to mention, we can do it where? Personal finance, paper 3, spreadsheet. Yes, we'll start it this week. Whenever we start the spreadsheet, you will find that In this Excel, you will put values, you will create equations, and then whenever you change the values, what will happen to the equation? They will recalculate themselves or you get different results. So if you would like to see your profit or your loss in something, you can just change the values and everything will be changed. So in this spreadsheet, you will find that even at the end, you can look at it and see it in graphs. Yes? So spreadsheet is an example of modeling used for finance. Very attractive in organizations and companies. Another example is what? Bridge and building design. Before I build the building, I need to set in mind certain factors. For example, how many stories is the building? How many stories in the building? The maximum load of the building. If there is an earthquake, will this building stand or it will fall? What about sandstorm? For tall building, you have a problem of wind coming from the side. If I have a tall building, you have problem of wind coming from the side. They might bend the building, by the way. You get it? That's why you'll find that tall building, they try to make them look like a circle, or they can have a smooth edges. Why? Why? So that the friction of the air will be less. There won't be any kind of a force, and this force will accumulate with time, and the building will start to bend, or at the end, yes, it will fall. The same goes for flood and water management. Whenever you are building a dam, for example, you will find that you have to put into considerations the maximum amount of water that will come, the minimum amount of water, when to open the gates, when to close the gates of the dam. Very good. What about traffic management? Nowadays, this is becoming very attractive. Traffic management, why it's attractive? Because if you have this kind of intersection, normally we have fixed lightning, isn't it? Fixed time in between this intersection. But if I have this kind of systems, I can put sensors in these roads. Pay attention, please. These questions came before and you might get it in the exam. You might need to put sensors to record the amount of car going in each direction during the day. Based on these sections, you will find, or you will see, or you will notice which one is more crowded and which one is less crowded. So the timing of the traffic light will be different, isn't it? Yes? So you'll have what we can call it a dynamic change in the timing. The timing will not be fixed. And you will notice that they make it not only during the day, because during the weekend it might differ, isn't it? The weekend, the whole traffic might differ. Are we good? During the night, different, isn't it? Less number of cars. So you can't set the same timing during the day, during the night. Someone will be just waiting there for 120 seconds for the light and no other car is crossing. You get it? But when you make it dynamic using this kind of sensors, everything will change based on the scenario. Everything will change based on these kind of scenarios. Same goes for what? Same goes for weather forecasting. What do? You put some sensors. Can you see the sensors down there? You can have rainfall, temperature sensor, wind direction, wind speed, pressure sensor, humidity sensors. You put them, and then based on the reading, you can draw this map that you will see on TV. What's happening in each and every part of the world. Are we good? When it's raining, when it's winter, when there is a storm, tsunamis, these kind of activities, you can actually predict them even in the future. So advantages and disadvantages of modeling.